Thank you so much. Today we have our new guest, Davit Buniatyan. He's a CEO and founder of ActiveLoop. It's something new for me, frankly. Being a student, I'm very happy to have Davit on our call. Welcome to otechtalks.tv. It's Open Tech Talk. So we'll learn today from Davit how he's doing, what he's doing now, and he can share with us his learning, life experiences, and all that. Welcome, Davit, to the show.
Thank you very much, Kashi, for hosting me. Great to be here and excited. And thanks for everyone for who is listening us. Hopefully, I will be helpful and useful sharing our insights with the audience here.
Thank you so much. So if someone new to the show and he wants to know who is Davit, how you brief him that, okay, this is the Davit, the guy, you are the right.
Sure. I'm the founding CEO of the company called ActiveLoop. We are based in Bay Area. Originally, I'm from Armenia. I did my high school there and then did my undergrad in UK and then moved to US to start my PhD. After 2 years of studying, actually took a leave of absence and then moved to Bay Area to solely focus on the company. And I'm very excited to share about the details, how to went.
All right. So you did the college, the university education, and then you did the PhD. So after completing the PhD, you started this company.
I haven't yet completed it, so essentially
you haven't yet completed. All right.
Yes, I actually dropped out like 2 or 3 months ago. The goal was like, okay, when I got into the PhD, before starting the PhD, I decided, okay, I'm not going to startups. I'm going to go into academy, try to be the best in one domain, and also hopefully become a professor.
Right.
And I did that decision already because before that I had some kind of entrepreneurial achievements, I'll say, like a very minor ones. But then I got really passionate about doing research, especially in machine learning and data infrastructure.
Okay.
But then after 2 years of getting all the insights, we got very excited about one idea, and we applied to Y Combinator, which is a startup accelerator here in Bay Area, and we got accepted. We thought this will be an internship, summer internship, and then we'll get back to our PhDs. But things totally changed after we started working on the company, the product we are building, and the issues that we are solving, essentially.
Okay. So now you use the word dropout. So it's mean you have made up your mind to stop it?
Yes, unfortunately, that's one of the decisions in life that I'm going to regret either way. So even if I choose to continue the PhD, not to do the company, then that's like a regretful decision in both options. So you have to sacrifice one thing to be able to get the other.
All right. So now it's quite becoming more interesting that you're sacrificing one thing, which is education, or maybe at that time you started it. So I wanted to hear, what is that, which leading this all that, okay, you need to more focus on this one, that maybe it's solving more business problems. So what is?
Well, one thing before I get started is actually you should never ever sacrifice education. As like also taking your example as well, like having so much experience in the industry, you are still back to taking a master's degree in AI ML. So that's like something to learn from you as well. So I think the best here is that you always have to learn. It doesn't matter if you are learning it in the like an academical environment or you're doing the learning yourself, but the education should never ever stop. This would be an active learning, and that's one of the kind of the mottos we have at ActiveLoop, that we should constantly learn. It doesn't matter if you are like a business or the goal is like the company should evolve and each of us should learn. Anyway, that's one point. But basically, the main idea why I've started the company is that when I was at Princeton, I was in a neuroscience lab.
Right.
Actually, when I applied to a computer vision lab, but my advisor left to Bay Area to start his own self-driving car company. So I had a choice to go to join his startup or start, like in the early days, or join another lab. So I decided actually I want to join the research lab. And what we were working was very exciting, is that we were taking a mouse brain and trying to reconstruct the connectivity of neurons inside the brain to understand how the brain learns or how the brain works. Me as a kind of a computer scientist in the neuroscience lab, I was mostly focused with dealing with infrastructure related problems. Like we had the volumetric image of a mouse brain, which was a petabyte scale data set. And we had to apply deep learning techniques to separate the neurons, find the connections, and then build the graph. So for example, one thing that we can prove out looking at this graph is that backpropagation, which is a very famous algorithm in machine learning, doesn't exist, at least in its form, inside the brain. And we were dealing with this massive amount of data. We were applying a lot of deep learning, like we had a huge data pipelines to process this data, and it was costing us a lot of money on the cloud. And our goal was to reduce to like petabyte scale processing to 2-3 times cheaper by rethinking how the data should be stored, how the data should be streamed from the storage to the computing machines. Should we use CPUs or GPUs, and what kind of models to use? And those kind of insights sparked the idea of starting the company. We got into Y Combinator, then raised our seed fund, and we have been working with early customers to help them to be more efficient in terms of their machine learning efforts. One of the customers we worked with, they had 80 million text documents, and their problem was to train on the so-called embedding models, which takes a text, put them into the vectors, so that you can run very efficient search on top. And to train those models, for them, it was taking 2 months. We helped them to reduce the training time to a week project, cut compute and storage cost, and also use much more sophisticated models to boost the performance. Then we worked with another company of ours. They have Intel, they have aerial images flying over the Illinois like agricultural fields, and their main goal is to provide insights to the farmers. And what we learned from them as well is that they have, again, petabyte scale data sets sitting on AWS, and they have to train those models to deploy these models for the farmers to provide insights. And starting from how you store the data, we help them to build the data pipelines from streaming from the storage to the computing machines. But what we learned so far is that there is no actually database for images, video, or audio. It's true, you can still use the current solution somehow, like put them, but if you look into what's recommended highly is that you still store all your like data or metadata in a database, like SQL database, like Oracle or MySQL or any other one. And then you have an additional column that points to the files on the file system or an object storage. So, and if you do like that, training a model directly on the data is very inefficient. You have data lakes where like you can store a lot of unstructured data, but it's mostly used for storing structured data. You have data warehouses that work for only semi-structured or maybe structured data sets as well. But when you talk about unstructured data, there's no any go-to data, I'll call it a store, for storing all this data so that you can efficiently run machine learning on top. And that's what ActiveLoop is doing. We are building we can think of it as a database for images, video, audio, text, that are all unstructured data, that you can efficiently store the data set and then stream this to the training processes to train a machine learning model, and then of course deploy these models on the cloud.
Okay, so now I will first go back to the first question. I think the answer which you said, the education, and I agree with you. I mean, and that should be priority. And when I started doing it, some small courses, 6 months, 3 months, and all that on AI or ML or data science, and while I was doing it, okay, it will support my professional life. But then I realized that maybe I need to go with some structured program. And that was the reason back in my mind that, okay, let's start the structured program, which will be 2 years or 2.5 years, and then I will be able to finish it. So I agree with you 100% that there is no alternative to that one, the formal education. And now comes back to the solution, which while you're working in the research lab and the huge, enormous amount of data, especially the images or the files which are not available and commonly goes to databases, which is SQL, Oracle, or all that. And you identified. Now, you mentioned when you were doing in the research lab, at that time you were working on 20 petabyte or the amount of data, and then you realize you're not getting any solution out of it, or maybe the cost was high, which you mentioned that when you were using it. Now, and then did you identify the solution over there, which become later on like an ActiveLoop proceeds? Or at that point of time, it comes in your mind, no, I need to find some way to solve the current problem. And how you reached a situation or a mindset that, yes, I'm solving a one problem, but this could be my future trade, or could be my company, or could be in a more vast area where I can invest. So how this comes in your mind as a student while you're working over there?
Yeah, that's a very interesting question. So first of all, our team at Princeton, they solved we solved the problem for storing this data. But the solution itself was only focused for storing biomedical images, which are like 4-dimensional data. That's it. You can't store like generic data sets for computer vision. If you have a self-driving car use case, if you have an aerial image use case, if you have agricultural use case, those were not supported. This was like a specialized focus on solving the data problem for large scale, it's called electron microscopy, or just like biomedical image processing. But one thing what I noticed is that the same solution, first of all, the same problems were apparent in other labs and also across the industry. That's number one point. And the same solution can be easily extended to other, like if you have only 4-dimensional data sets, you can actually have, why not have 3-dimensional or 5-dimensional, whatever. So that, I think that was the company idea. So, okay, we can take this. This was a highly specialized, very performant solution for a specific use case. We can take this and extend it to other use cases and make it useful for other companies or other labs in the area.
Okay, so now if take an example, if I'm working in one company and I need to have a huge amount of data, and with the option A, which is available to store somewhere, the way traditional things are happening on any database. Now, if I need to come to you as an ActiveLoop, so what I need to do? I mean, how your process works? Is it a platform? Is it some subscription, or do I need to download somewhere, install it, or how your model works?
First of all, when you have a lot of this, like images or videos, let's say, this first question you ask, where do I store this data?
Right.
If you say I want to store it in a database, then the problem is that the data is so big, then storing in memory is first of all very expensive and also very hard to scale with standard SQL databases. So that's the first question you have to answer before even talking to us. Then the next questions are, okay, it seems like I have the option of storing on the files and on file system. Let's say I have a very big distributed file system, or I can have the option to store on object storage like S3 on AWS or Google Cloud Storage. Do you have those options? Now the question is, okay, how efficient is it? Then you start answering, can my data science team start immediately working with this data set, or I have to help them to build all the data pipelines and do the data engineering work for them, and so on. So at that point, ActiveLoop comes into the place. We have an open source format for storing these data sets on object storage, on top of object storage. So let's say you have 1,000,000 images and you have 1,000,000 labels for the images, each label saying this is a dog or cat. And you and your data science team wants to train those models, or let's say they do want to do some analysis. So what we do offer is like a very simple Python package that you can just run on your command line CLI, like pip install hub, which is open source. We have a community of users, a Slack community of 600 engineers, and what you do is that you take the Python package, which gives you an API, and you start appending the images inside this API. What it does behind the scenes, it creates so-called tensors, which are n-dimensional arrays for both images and labels. So we will have one tensor which will be 1,000,000 by 512 by 512 by 3, and then another tensor which is 1 by 1,000,000 as like a single small tensor. You can think of tensors as the same way as columns inside a tabular dataset, and then the dataset itself is a table for now for machine learning purposes. But one interesting thing here is that for deep learning, especially, or machine learning in general, models, they do take input as a tensor and output another tensor. So they don't really care if it's an image or a video. They do care it's like it has the standard input and output in terms of the arrays. Now you can very easily learn a function that goes from one tensor, which is the images, to the labels. And the models can, and your dataset can actually have multiple tensors, and your model can actually take multiple in tensors and then output another 2 or 3 tensors. So basically, what we did with the open source format for now, what we did is that we took all this data and then transformed into a native language that deep learning like frameworks work.
Right.
So you can run it very efficiently. You can think of the ActiveLoop Hub project as like a Parquet, but for images, video, audio, text. Now, if you're not familiar with Parquet, Parquet is the kind of state-of-the-art storing like format for tabular data, and on top of that, you can build a kind of a data warehouse or data lake. And then we are another kind of a format for specialized for unstructured data sets. One thing as well to mention is that when we started the open source last year, it has been growing 70% month over month. And it got picked #2 trending across all GitHub repositories earlier this February.
Okay.
Do you know what was #1 at that time? So it was a crypto trading bot. So we couldn't convince the world that, hey, like it's a better way to store the data rather than actually you make easy money using crypto.
Easy money. All right. So it's open source. So how your commercial model then comes into play?
So similar to other databases and like open source or open core go-to-market strategies, we also build a managed version of the storage. So I don't know if you're familiar, there's a MongoDB, which is open source. You can also get MongoDB Atlas. The same goes for us as well. We do provide a managed service, where it allows you to, first of all, manage all your datasets across multiple repositories on AWS, Google Cloud, so you have a single bird's eye view of all your data. Secondly, we do provide visualization. So you can visualize million images at the same time on the browser with the data getting streamed from the storage to the browser without any middleman. So there's no any like kind of a background rendering job that someone is doing. The data directly fetches the browser, directly fetches the data set from your desired location to the browser. And you can visualize the data instantly, which is a major problem with data scientists, especially in computer vision domain, when they train models with their eyes closed, in other words. The third thing is about the performance. So we can, the way we store the data allows you to start, let's say, hundreds or thousands of compute machines, all of them having access to the data set as if this data set was local to the machine, which means that we can stream the data from the object storage to the computing machines and feed this to the GPUs with 100% GPU utilization without going through the file system and then going through all the bottlenecks. So now on the cloud, instead of each of the machines having, let's say, 100 GB of data set local storage, they now have a view of real-time data of 100 or petabyte here, but it could be elastically scaled to any size without using a distributed file system like Elastic File System, for example, or network.
And for customer, is it like subscription, or how is it for customer?
It's a usage-based pricing.
Usage-based. Okay. So I need to have my object storage in cloud, and then I need to subscribe to your ActiveLoop managed service, and this managed service will access my object storage like it's a data pipe, all right, and then even on top of it, you provide the visualization. That's another functionality,
right?
Compared to the open.
Yes.
Okay. All right. And this usage is metrics is what when you say usage-based metrics.
So let's say you want to start a cluster.
Okay.
And then you run a compute on this cluster. You want to transform the data, or you want to run a query on this large-scale data. Similar to Databricks or Snowflake model, we are still early, but we are brainstorming on having this kind of usage-based pricing on top of this. But it's still super early, so we're like a kind of pre-Series A startup, just for everyone to clear. A lot of things can change over the time, and we are iterating. But this is like kind of the initial idea, what we have, how we think that our long-term pricing strategy is going to work.
All right. Very good. Excellent. I think it's a good sounds from a challenging point of view, and there is a general requirement, and then on top of it, support the open source, and then refer to the commercial customers they're going to do. Okay. Now let's go back to the mindset of as a startup mindset. That when you started, what was the common advice you were getting, which we should ignore it?
Oh, the advice that I should ignore?
Yeah, which was the not the right advices you are getting it. When you start some new business or anything new, so many advices keep coming from here and there. How to
Well,
filter it? Let me
God,
say, yeah,
that's a
how you are
good question.
filtering
I
it?
can tell you like good advice I got, but
How you are filtering
filtering
it? How you are filtering it? How you are filtering it?
I think one of the things that Y Combinator taught us very well is instead of hearing the external advice, like focus on the customers. So whatever advisors may tell you, the other people in the like the VCs will tell you, hey, this is
Right.
going to work or this is not going to work. Maybe you have super bright employee team members, founding team members, they can like to use like, hey, this is definitely is going to work, or like let's do this way or the other way. I think the most important aspect is things can get very exciting and things can get very devastating. Like you can get disappointed. That's like a kind of a sinusoid startup life. But I think you should prioritize on the customer input there in any choice there you have. So I think that's one of the key things. And it's very difficult to follow because you have all these insights or the bias about how the world should look like. And sometimes it doesn't work. And then you have to make sure that the reality that you are seeing is kind of connected with the whatever like state of the mind you have at that point and while you are making those decisions. I think that's one of the and to be honest, it's not like easy to follow on my side as well, but still like this should be done. So I wouldn't say like filter out those advice that people give you are bad or wrong. Like I think prioritize the customer advice or the customer input as high as possible compared to the other inputs you get from anyone else.
Right. Very good. And thank you. And how you got the first customers, your early customers, how you got those one?
So the early customers, we went from our network and then also through our investor networks, like the two examples that I've shown here is like we're coming from the investor network was pretty helpful and useful. I think the general strategy is you start solving a problem that either you had at previous company or you have in your near network, at least few, like if you're talking about enterprise, then few customers you can get easily on board. Then you can expand this network through the affiliated members of the company. And of course, then you start building a sales team and then going after like building a more kind of a pipeline approach of outreaching those customers that you don't know and then trying to get them on board and run a demo and then close the contract.
Right. So do you have now the sales team? How you are going now to the market?
Yeah, currently we do have a team, but like a team of a single person on the sales side. We have intentionally decided not yet to start pushing the kind of the sales effort. We had an opportunity actually to kind of, I said acquire, but like get a team of sales engineers into the team as soon as possible. The main idea is that with the open core go-to-market strategy, you have already kind of a pipeline from the coming from the open source users that ask for this features, that features. So currently our more needs are getting more engineers into fixing or making better enhancements the open source plus the enterprise version, rather than actually start increasing the pipeline. Once we are there where like we have this very smooth onboarding process with the customers we have already, then it's like just becomes numbers game to increase the user base.
Okay. And how you were able to manage a one man who's working on the models and data pipeline and the machine learning, algorithms, Pythons to managing the people, becoming the founder, CEO. So how you transitioned yourself from that role to now? So what helps you? What traits, what secrets you used?
Well, to be honest, I have a lot of kind of parallels between how you train an ML model and how you build a company, or how you build a model, how you build a company. So for those, like I'll nerd out a little bit here. Basically, building a startup is finding a way your company can like plug into the revenue stream as a loss function, or some kind of a loss function. And then your goal as a founder to make sure that the your company is differentiable. In machine learning, differentiable means that the input that comes from the output, let's say from the revenue stream, you can easily backpropagate through all the layers of your company. And then you can update the parameters basically, or the company structure, so that you can increase or optimize for more, I'll say revenue, but like revenue can be a proxy to another options as well. Like revenue is the most like the common thing, but you can choose any other metric as well as a founder. But your goal is to make this like kind of a differentiable process. Once it's differentiable, then you have a product market fit, which means that you can start now optimizing the landscape and just get for the most revenue. I think for one of the advice that we got from the founder of Y Combinator, who basically told us that building he asked first, are you all like PhDs and you know math and whatever? Like, do you know what is optimization? So for those people who know optimization will be easy. Basically building a company in an expanding market, like an AI and ML and data infrastructure and so on, is like, you just need to optimize for the revenue. So get like you think you might get a local minima, which basically means that you are, let's say on a local, like you are climbing a mountain, but you are on a mini mountain and you don't know, there's no way you can go higher. Basically, the assumption there is that if the mountain is getting bigger and bigger, then there is no any local minima. So every time you climb the mountain, you actually get into the large mountain. This is kind of an advice we're trying to follow.
Very good. Very good analogy. Very good analogy. Very good, excellent. I like it. I like it. And now I think that the key takeaway which I wanted to get out of this one, because people want to, like any engineers or nowadays university students and all that, or even the professionals, they want to get quickly into startup mode, that okay, this is, I have got some idea and I need to pitch somewhere. So anything which help you to pitch to the right way, or any lessons which you learned it while solving the problem, okay, but how you tested it, that this is the problem which I'm solving it. Maybe while you were doing it in Princeton, that was maybe it was a one unique case. So there could be an argument against that, okay, this is not a common problem which you're going to solve. So how you verified or tested, or maybe you checked, yeah, this is, I think it's a wider community problem.
First of all, before even testing, there are 3 steps you have to do. The first one is like pick the problem. Right. So you can go and pick a very wide problem that everyone has, but then you also have a lot of people solving this problem. Or either it's solved, or it's people are like already crunching and solving this problem. And the question you should answer there, okay, is there a way I can give you a very differentiable, like meaning the differentiated solution there? Like it's 10x better what others are doing or what others can do as well. So that's like picking problem itself. Right. So basically, even before getting to the testing or validation process, you already affect how this is going to have impact by thinking of like, okay, how I'm going to subset the problem set. And very, very actually useful framework that I've read. There's a book called Good to Great, which have this like hedgehog concept, where you draw 3 circles. The first circle is about what you are most excited about. The third one where you can be the best in the world, and the third one is that where you can create the most value. And then you put all the points that you can do, and then you pick the in the middle overlaps with this 3, and then you just focus on that. So that's like about the focus on then like picking the problem, focusing on it. And the third one is about validating or testing if this hypothesis is correct or not. And then I think the best way is you can validate in the early days where you don't have too much metrics, obviously, is to see if you can get few customers or users who are very, very excited about your product or the solution that you're building. Then if you have achieved that, then the second like iteration is like adding metrics. There are like different ways of measuring if the product is working or not. One thing that we use internally is about using the retention, like weekly retention, if the retention is high or it's like has a strict slope in the below that goes till the end. That's how to measure. Another way of, I think, the founder of Superhuman was measuring, is surveying the users and asking if how much you will get disappointed if this product will not be there tomorrow, and then measure. There's like if 40% more people say they will be very disappointed, then it means that you have product market fit. So it's like basically you have validated your assumption or hypothesis that you had about the product. And then of course the true ultimate validation is that you actually create a value and people are paying you for that value, or people are giving you money for that. So that's the best, the way you can validate a certain hypothesis problem.
Right. All right. Very good. Excellent. And now, if as you are expanding your team, either you're hiring engineers or the researchers or the data scientists. So, what are the key traits you're looking from a candidate? So maybe before going to closure of the cover session, so some of the tips which you can share with the new. What are the new talents which you're looking for? So how you're deciding that this is the right fit for my company or my startup?
So there are two parts in our kind of hiring process. The first part is about skills and knowledge they have, and the second part is about like their soft skills and like the culture fit, basically. On the first part, what we are looking for is those people who have experience with machine learning and computer infrastructure at the same time. Usually you have data scientists or machine learning engineers who just know machine learning, and they don't want to touch like any DevOpsy or software engineering stuff. And or you have super good talented software engineers who don't know anything about machine learning. True. And then you have basically this kind of one is like more academical mind, state of the mind, and the other one is like more kind of builder's mind. And it is difficult to have them both at the same time. And since we are building a tool that's going to serve to very advanced people, you both need to make sure that the software itself is very high quality, and it's also solving a problem that machine learning have people. So that's number one. And so you have to know like at least deep learning and distributed systems and engineering to go for this. It's like the same way as early days of Oracle, where nobody knew what is a database, and we are building one, but how are we going to build one if nobody knows how to build one, and so on. So the second part is the, by the way, one thing to mention as well is like currently like deep learning engineers work with the data as the same way as developers used to work in pre-database era. So that's like kind of the same space. True. And the second skill, what we like in terms of soft skill culture fit, what we are looking for is people who are very proactive, passionate about the vision and the company, the kind of the where the industry is moving to. And of course, the soft skills like thriving in ambiguity. There's a lot of uncertainty, how you can solve all these problems, like people who enjoy this stuff. That's the third, I'll say, the kind of culture aspect of the approach. But there could be case that the candidate doesn't tick off on any of those. And then, but we click so well, so it's like, yeah, sure, we should go ahead together. Or it could be the otherwise as well. It's like the candidate is perfect, like, well, the skills and culture fit, but there's something is we think that long-term won't work for neither us for that or for that candidate. Then like it's kind of, you have to make sure that's a win-win situation, both for the candidate and for the company. True.
And I think I agree with you, because even nowadays, I think the current my subject, I think, artificial intelligence system engineering, where, we never thought about it that, okay, how actually the earlier software developed them, but now how we need to embed them, ML or AI, into deploying it, either Kubernetes, Docker, and all those areas that are, because this was missing. So even if I try and talk myself, I was in this part of the world, and and then now learning with AI and ML, then I'm trying to connect it. Oh, okay, this is how it's gonna work.
You say, oh, we have here these tools, but where are the tools here? There's no one is doing this.
Yeah,
so that's kind of the idea.
That's true. All right. Thank you so much for joining. So before we will close our today's call, I usually ask this question to everyone, because this is one of my favorite questions. So sure. What is the one thing you wish before starting? What is it's even in career, even in something, even I'm developing it, or even in a solution. So I used to think, oh, okay, maybe what was the one thing which I should know before I starting this any development or M&I?
The number one important thing that I wish I would have known before starting the company is about having patience.
Oh.
Patience, building the especially in data infrastructure, B2B is not like a mobile application. You can get a feedback and like instantly update the website or whatever, like the push another update. You're building a data infra tool, and you have to be very careful in changing, testing, and framework and everything. So there's both in the development, then about the product, and also about the sales. So sales cycles are also very long. So key thing I wish I had more, I would say patience is the best.
Thank you so much, David, for the very wonderful conversation and good. I think the takeaways for even someone new starting it, and even from a AI and a data science point of view, who is trying to work on images or even the large data sets. And I think I'm going to use your hub, by the way. I just come to know, I got to know from this when I approached you for the session. Oh, I said, yeah, really? This is some inspiring, because we were having some task in my last subject 2 months back to work. It was a deep learning, the subject. So we were trying to figure out so many things during the course. So I think good. Thank you so much for joining. Any last comments you want to share with us? Definitely, I wish you good luck with your new venture, and I hope that. And I think you are filling the gap. That's what I can tell you based on my own personal judgment.
Thank you very much, Kashi, for having me. First of all, join our community as well, and let us know if you have any questions. Happy to help in terms of the onboarding, the hub, and everything. On this part is like, I really appreciate the time we spent and also the nice questions you had for us. So great conversation, and looking forward to see how it can be helpful.
Sure. Thank you so much. Thank you. Bye-bye.
Thank you.